In this video, we're going to be talking about how to determine the molecular formula from the name of an ionic compound using a third method on how to do this. And I like this method the best. I call this the crisscross method because all you're doing is you're going criss and cross, and you're going to solve the question. So I'm introducing this method last because it's important to understand the underlying reasons for why we do things instead of just memorizing how to do it. But this is going to be by far the fastest method on how to solve this, and it will also always get you the right answer. So I like to do it this way. But make sure you watch the other videos first so that we understand the reasoning why this works and why we're doing what we're doing, because that's the most important thing in education, understanding the why. Don't just memorize. Anyway, what we're doing here, so we're going to go through the same examples that we did before, starting with magnesium chloride. So magnesium chloride, and we're going to do it kind of similar to that last method of balancing ions to zero. We are going to do, we're going to write down, let's write down what we have, magnesium chloride. And magnesium chloride, again, is made up of magnesium and chlorine. And so we're going to write out the element with the charge that it has. Magnesium has a +2 charge, and chlorine has a -1 charge. I'm going to write the charges in a different color. Chlorine has a positive or a -1 charge. All right, and then all we're going to do in this method is I'm going to take this number right here. I'm going to write it right here. And then I'm going to take this number right here, and I'm going to write it right here. So we're going to end up getting our final answer of Mg, magnesium, with only one of them, except we don't write the one. Don't write the ones. And chlorine with, we said there is a 2 right there. So magnesium chloride, and we write the 2 there because we just do the crisscross method. All right, let's do another example. And this is going to be by far the easiest way to do aluminum oxide. So aluminum it's on the third group, so it has a +3 charge. And chlorine, yeah, we'll do the charge in a color, it doesn't matter. +3 charge. Chlorine, or not chlorine, oxygen has a -2 charge. So we're going to do our crisscross method. I'm going to write this 3 right here. We're just going to ignore the charge, write the 3 right here. We're going to write it right here. And then we're going to write the 2 right here. All right, so we go crisscross, and then voila, we get our answer of Al, and we have 2 aluminums, and then we write O, and there are 3 oxygens. All right, so by far my favorite method because it's just super fast. But again, I don't want us to just do this and just memorize what we're doing. It has to make sense to us. It has to make sense that maybe we don't have to understand the mechanisms, the mathematics behind why we can just crisscross this. But I do want us to understand that by doing this, we are balancing the ions to zero, or we are visually showing that that's every electron is accounted for and attached to something, or not attached, but given away and accepted. So it's important to understand the why we're doing what we're doing. But sure, once we understand that, we can do a shortcut. All right, a couple of important things with this method. Let's do another example just to show something that's going to be important to do that some of you might forget. If I have an example like, let's say I have calcium oxide. Let's do calcium oxide. So calcium has a positive 2 charge, and then oxygen has a negative 2 charge. All right. And then we do our crisscross method, and we said that the 2 is going to get written right here, and then we're going to write this 2, we're going to write it right here. So we're going to get a final product of Ca2O2, right? But something very, very important that we need to be mindful of when we do this method is we have to simplify this. Sometimes by doing the crisscross method, initially we're going to get a larger number of each element than we actually need. We need it to be simplified. So this is going to be incorrect because it can be simplified. And if it can be simplified, then it needs to be simplified. If you write it like this, it is completely wrong. So we're going to simplify this, and we're going to write it as, we're going to simplify, we can divide by 2, so we're going to say CaO. I can't write CaO. All right, where we have 1 calcium and 1 oxygen, but we don't need to write the 1s. So just the biggest thing with the crisscross method, you're probably not going to mess up a whole lot, but if you do mess up, it's probably going to be from not simplifying. So make sure that you simplify. So I'm going to actually write that. Make sure answer is simplified. And if you do that, then you're probably good to go and you can use this method. But again, make sure we understand the reasoning why, why we're doing what we're doing, because that is incredibly important.